Good morning, everyone. So, let us see the ARM assembly language programming where we are going to see the examples of load and store instructions. So, this is the second lecture of our ARM assembly language programming. Let us assume there is a number that is saved in memory in this format. So the number is saved in memory in little endian format. So little endian means lower address corresponds to lowest byte. So this is the lowest byte and this is the highest byte. And a word corresponds to 32 bits. So in little endian format, if you are considering a 32-bit number, it will be saved in this format from bottom to above. So this will be like read as 78, 56, 34, 12, assuming it's a 32-bit number. And similarly, this 32-bit number also will be read as FFEFCDAB, provided it is in little endian format. If it was saved in big endian format in the processor, it will be read as, the first number will be read as 12, 34, 56, 78. And the second number also will be ABCDEFFF. So we'll assume the processor we used follows the little endian format in memory. So this instruction LDR R0, hash 0x1 followed by 7 zeros will load the value 1 followed by 7 zeros to R0. So this is equivalent to R0 equals 1 followed by 7 zeros. So this is the immediate value is loaded into R0. Now what are the different formats? The first one is LDR R1, bracket R0. So the R1 will be loaded with the value from pointed by R0. That is the meaning. So what is the value in R0? This one. So the LDR R1, bracket R0, the processor goes to the memory, and since it is LDR, a 32 bits will be loaded from memory following little endian format, since that is the format that is being processed by the processor. So we'll have LDR R1, bracket R0. The value 4 bytes of value from the memory will be loaded to R1. So it will be 78, 56, 34, 12. This value will be loaded to R1. So that is the answer, 78, 56, 34, 12. We assume here this is a continuous program where each instruction carries forward from the previous instruction. So LDR B R1, bracket R0. So it is byte. So one byte will be loaded into R1 pointed by R0. So R0 value, there is no change here. So 12 will be loaded to R1. So that is the answer. So 12 will be loaded to R1. Next is LDR H R1, bracket R0. So again R0 remains the same. So it's a half word that is going to be loaded. So 3412 will be loaded to R1. Now LDR B R1, bracket R0, hash 1. So this follows the 3 operand format. So in ARM, most of the instructions of ARM will follow either a 2 operand format or a 3 operand format. This is a 2 operand format where there are only 2 operands. But this is a 3 operand format where 3 operands are there. Now what this will do? R1 will be loaded with the value pointed by R0. After that R0 will get incremented by 1. That is the meaning. So this actually corresponds to post indexing. So this is called post indexing. And this is called offset. So R1 will be loaded with the value pointed by R0, which was equal to 12. So that will be loaded to R1. After that R0 will get incremented by 1. So R0 will become 1 7 zeros followed 1 6 zeros followed by 1. Now LDRB R1 R0, hash 1. So here we are assuming the program is written sequentially. The instructions are continuous. So in this is called pre-indexing. So pre-indexing means R0 will get incremented by 1, and after that R1 will be loaded with the value pointed by R0. So R0 will become what? Here it was 1 6 zeros and 1. So here it becomes 1 6 zeros and 2. So in 1 6 zeros and 2 the value is 56. So 56 so 1 6 zeros and 1. So in 1 6 zeros and 2 the value is 56. So this has to be 56. And then R0 will remain the same. there is no change in R0. So here you need to know R1 will get in the fourth step, R1 will get loaded with the value from pointed by R0. So which was 12. Then R0 got incremented by 1. Here R0 will get incremented by 1 first, but it won't be returned back. R0 will remain the same, but R0 will get incremented by 1 and the value will be taken. So 56 will be taken. Then R0 will remain the same, no change. But if you write LDRB R1, R0, #1 with an exclamation, what will happen is, again, R0 was 1 6 zeros and 1. So first R0 will become 1 6 zeros and 2, and the value 56 will be loaded from there. After that, R0 will get returned back. So this is also pre-indexing, but it is write back also. Here write back is also done. Write back means the register will be returned back with the value. So here if you see, R0 will become R0 plus 1. So R0 here was 1 6 zeros and 1. There was no return back here. So it becomes 1 6 zeros and 2, and the value will be loaded to R1. So 56 will be loaded to R1. Then R0 will get incremented by the return back by the value incremented. So it becomes 1 6 zeros and 2. Now in the next step, if you write LDR R1 comma bracket R0, here R0 was equal to 1 6 zeros and 2. So it will cause a memory misalignment problem, because like we discussed in the previous lecture, all words should be aligned by divisible by 4. So all memory addresses, when we are loading a word, it should be divisible by 4. So if it's not divisible by 4, it will give a memory misalignment problem. In the case of half word, all the memory addresses, that is a starting address where we are pointing, should be divisible by 2 when it's a half word. Otherwise, memory misalignment problem will come. For a byte, no issues are there. Now LDRH R1, R0, #2. So again, R0 was 1 6 zeros and 2. So in 1 6 zeros and 2, these are the two bytes. So 78 56 will be loaded to R1, and R0 will get incremented by 2 because this is post indexing 1 6 zeros and 4. LDR R1, R0, #4. Now this is okay because R0 is 1 6 zeros and 4. This is divisible by 4. So from the pointed by 4, from here the 4 bytes will be loaded. So what are the 4 bytes? From bottom to top, FFEFCDAB. So FFEFCDAB will be loaded to R1. Then R0 will get incremented by 4. R0 becomes 1 6 zeros and 8. Now LDR R1, R0, #4 exclamation. So what this will do? R0 will get incremented by 4. So R0 becomes 1 6 zeros and C. And then from that location, from this location, the value will be loaded to R1. Okay, so R0 will be returned back also. All of the above operations are applicable for store also. str R1, bracket R0 will save the value of R1 to the address pointed by R0 in 4 consecutive locations. But this address has to be, the starting address has to be divisible by 4. strB R1, bracket R0 will load the lowest byte in R1 to the address pointed by R0. strH R1, bracket R0 will store the half word, that is the lowest two bytes in R1 to the address pointed by R0, but again R0 has to be divisible by 2. strB R1, bracket R0, #1, the value pointed by R0 will be first loaded to R1, then R0 will get incremented by 1. That is what will happen. This is called post indexing. strB R1, R0, #1. R1 will be loaded with the value pointed by R0 plus 1, but no change in R0. You need to remember that R0 will remain the same, no write back. strB R1, R0, #1 exclamation. What this will happen is, R1 will be loaded with the value pointed by R0 plus 1, and then R0 will be returned back R0 plus 1. The same R0 plus 1 will be returned back to R0. That is how it works. So you need to clearly understand. So R0, when there is an exclamation, R0 will be returned back with this R0 plus 4. And from the same R0 plus 4, R1 will be loaded also. So hope it clears. We will see the simulator tool in the next lecture. Thank you.